Hello everyone, let's try to be a cheat code ninja today. In this problem, we are given a sorted array where every element appears exactly twice, except for one element which appears exactly once. And we have to find the single element that appears only once. It is also given in the problem that our algorithm must run in logarithmic time. Let's try to come up with an intuitive solution for this. Let's see how we could solve this problem if we were allowed to do it in linear time. One thing you can observe is that each element in the array except for our answer will form a pair. So if we were able to somehow cancel out all these pairs, we'll be left with only our answer. There's one way we could do that using the XOR operator because the XOR of same elements will cancel out and return 0. So we'll start with 0 and XOR each element in the array and each pair would get cancelled out and only the XOR of 0 and our answer will remain, which will result in our answer. Let's try to identify some more patterns for each element in the pair. If we just consider the left element in the pair, the number to the left of it will be smaller than it and the number to the right of it will be the same. And now when we consider the right element in the pair, the number to the left of it will be the same and the number to the right of it will be larger than it. But when we look at the element which occurs only once, the number to the left of it will be smaller than it and the number to the right of it will be larger than it. So we can scan all the elements in the array and whichever element satisfies this property will be our answer. Let's see how we can use this property in our optimized solution. Since we have to come up with a solution in logarithmic time, and it is already given that our input array is sorted in ascending order, we should try to think in the direction of a binary search solution. But you might be wondering, how do we apply a binary search solution over here? For example, when we start our binary search and find the middle element, the problem is how do we determine in which direction we should continue a binary search. Let's try to figure out some more properties using an array in which all the elements occur twice. If we take a look at the indices of elements in a pair, all the left elements in the pair are at an even index and all the right elements in the pair occur at an odd index. Now when we delete an element from the array such that it results in our original problem, for all the pairs occurring to the right of it, the left element will now be at an odd index and the right element will now be at an even index. And for all the pairs that occur to the left of it, the original property will still remain and all the left elements will be at the even index and all the right elements will be at the odd index. So whenever a single element occurs, it changes this property of the odd and even indices of the left and the right elements in the pair. We can use this property whenever we come across a middle element in the binary search. If we notice a change in the properties, that means our single element has already occurred on the left and we should continue our binary search in the left direction. If a property is the same as the complete array, where the left element occurs at the even index and the right element occurs at the odd index, that means we have not yet encountered the single element and hence we should continue our binary search in the right direction. Let's understand this with a complete example. We'll start our binary search and find the middle element. We see that our middle index is even and the number on it is a right element of the pair. It means that there has been a change in the original property. So our single element must have occurred somewhere on the left. So we'll continue our binary search in the left direction. Our next middle index is an odd number and the element corresponding to it is a right element of a pair. This is the same as the property of a complete array. So it means that we have not yet encountered our single element that has altered the property. So we should continue our binary search in the right direction. For our next middle element, we see that the element to the left of it is smaller than it and the element to the right of it is larger than it. This is a property that can only belong to a single element, hence this is our answer. Now let's implement our solution. Let's keep a variable for the length of the array. Our initial left pointer for the binary search will be 0 and the right pointer will be the last element. We'll continue our binary search till our left pointer will be less than or equal to the right pointer. We'll find our middle index by taking the sum of the left and the right pointers and then integer dividing it by 2. Let's keep a variable to store our middle element. Similarly, we'll keep a variable to store the left element. The index corresponding to it will be m-1. We have to be careful for the case when our middle element is at the 0th index. In that case, there will be no left element, hence we'll set it to none. Similarly, we'll store the right element, and for the case when our middle element occurs at the last position, there will be no right element, hence we'll set it to none. Now we'll first check if our middle element is indeed our single element. In that case, the middle element will be different from the left element, and it will also be different from the right element. So in that case, we can directly return our middle element as the answer. Now we'll handle the case when our middle element occurs at an even index. We know that for a complete array, the left element in the pair occurs at an even index, and the right element to it will be the same. Since our middle element occurs at an even index, if it is equal to the next element, it means that it is the left element of a pair, and our original property is still maintained and we have not yet encountered our single element. So we should continue our binary search in the right direction. Otherwise, it means that our original property for the complete array has changed. So we have already encountered our single element in the left, and hence we should continue our binary search in the left direction. Now we'll handle the case when our middle element occurs at an odd index. We'll now check if our middle element is the right element of a pair, so it must be equal to the left element. This would mean that the original property of a complete array is still maintained. Hence we have not yet encountered our single element, so we should continue our binary search in the right direction. Otherwise, it would mean that our original property has changed, so we have encountered the single element on the left, hence we should continue our binary search in the left direction. It is given in the problem that the single element exists in the array, so we'll encounter it once using our first condition, so we'll get our answer in this loop itself. We are now done with our solution, let's submit it. You can see that our solution is accepted. If you have any doubts, concerns or feedback regarding this solution, please mention in the comments. If this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.